Good morning, everyone. How are you doing? Welcome back to this channel again. I am Ridwan. Now, today we're going to start with differential calculus, that's differentiation. But before then, let me just tell you about this. In this channel, I will be taking you through all these concepts as far as calculus is concerned. Mind you, although in calculus, we have more than all this. There are so many concepts under calculus. But for now in this channel, we'll be talking about all this: differentiation, application of differentiation, integration, application of integration, partial differentiation, application of partial differentiation, where we'll be using Jacobian and some other applications. So we have applications to different areas: engineering, technology, science, different ways. We are going to see the applications of some of these concepts with reference to those fields. Then we'll be talking about ODE, that is ordinary differential equation. Here we will be talking about first order ordinary differential equation, second order, third order, and higher order. Application of ODE, where can we apply ODE to engineering, maybe mechanical, electrical, chemical, medical. So we have so many applications in different areas. Then we'll be talking about multiple integrals, double and triple. And also we'll be talking about the applications as well. Where can we use all those multiple integrals? Laplace transformation. Laplace transform, we see how we can, this one is actually on integral calculus. We see how we can use Laplace transform, different ways of finding Laplace transform of many functions. And then the application, how do we use Laplace transform to solve ODE, which is ordinary differential equation? Because under ordinary differential equation, whether first order or second order, we have so many approach, we have so many methods in solving them. So here, when we get to Laplace transform, we see how to use Laplace transform to solve ODE. Okay. Now here we are going to start with differentiation. Okay. So just follow me. We are going to start with differentiation. Now, under differentiation alone, we have so many beautiful concepts. Okay. Now, when we are talking about differentiation, although the differentiation, before we can talk about the differentiation, we'll be talking about variables, dependent variables, independent variables. But before then, differentiation is actually coming from the angle of limits, to find the limit of something. So, but here, to keep everything simple, because people really want to know, what is the meaning of the ydx? That differentiation is difficult, is this, is that. So we actually want to show to people that, mind you, it is not difficult, very simple. And another thing is, whenever I want to differentiate any dependent variable with respect to the independent variable, the thing is, we can use so many approach, we can use so many methods, especially the one we call differentiating from the first principle. I will not be doing that here. I will create a separate class where we'll be differentiating many functions from first principle. Okay, we get that. But here, we just have to know some basic things. So we are going to start from very basic, up to the advanced part, just like the way I have shown us. So the first thing we are going to discuss under differentiation is, so let me say number one, so differentiation as a whole. So number one, let's talk about derivative of something like x raised to power n. That's the first thing. Anytime we have something like this, x raised to power n, so we can say let y to be x raised to power of n. Okay, there are ways to prove all these things though, but we are not interested in the proofs in this video. Okay, now, well, let me say for now, y here is a dependent variable, x is independent variable, x has power of n. Are you with me? What does that mean? That is, y is depending on x. It is whatever the value of x, that we have, that is what will determine the value of y. Okay, but whenever we have something like this, we now say that derivative of x raised to power n, so dy over dx. That is derivative of y with respect to x. Derivative of the what? The dependent variable. You are differentiating dependent variable with respect to what? Independent variable x. This one is just a value, okay, a normal constant. So which can be 2, 3, minus 4, minus, you understand? The y dx will now become, what is coefficient here? 1. Multiply by, you will bring this n to come and mean this one times n, this n times 1, that is here, then x, this x, then raised to power n minus 1. You subtract 1 from the power. Two things, very simple. Multiply the power n by this one, which is the coefficient. That's the first thing. The second thing is subtract 1 from this n. Very beautiful. This will now become 1 times n, that's n. Nx raised to power n minus 1. Beautiful. That is what you just know. That means anytime you have y is x raised to power n, just know that the y dx will just be what? Nx raised to power n minus 1. Okay? Now, example here, okay? Example. So find the derivative of Roman figure 1, x raised to power 2, or let me say x raised to power 3, Roman figure 2, x raised to power minus 4, okay, and what? Roman figure 3, let me say cube root of x raised to power 2. Can you see that now? Look at this, everybody. Now let's go there. Solution. So the first one is what? X raised to power 3. What will you say? Just say let y to be x raised to power of 3. Simple. Which is exactly like this. What will you now do? You now find the y dx by using this formula. You now see. Therefore, the y dx of this is now what? Now, if you compare this with this, I have here 1. I have 1 here. I have what? N here. I have 3 here. That means n is 3. Beautiful. So what will you now do? You use this formula, which means you bring n to here. That is, what is n? 3. Then x raised to power what? N minus 1. That's raised to power 3 minus 1. That's going to be 3x raised to power 2. Beautiful. Are we getting it, everyone? That's lovely. Now, Roman figure 2. Roman figure 2. That's what? X raised to power minus 4. They say let what? Y to be x raised to power of minus 4. Are you with me? Good. What we now say, therefore, the y, the x now is what? Bring minus 4 here, that's minus 4. X raised to power minus 4 minus 1. Because if you compare this x raised to power minus 4 with x raised to power n, our x is still x, our n here is now minus 4. So we just use the formula. There's no any difficulty. So what we now do, simplify for that. To now become minus 4, x raised to power what? Minus 4 minus 1, that's minus 5. You know what? If you check this one, you remember in one of our series, in the laws of indices. If you have not checked that, you can just check my series on laws of indices. We have 5 parts: part 1, part 2, part 3, part 4, part 5. So we have made perfect justification on those indices. We solved so many equations, we solved so many problems, and we implemented some of those laws. So look at that. I can, from the laws of indices, I can rewrite x raised to a minus 5. I cannot stop here because we have to simplify. Simplification means reduce to the lowest term, to the term that, to the minimum, okay? So I will, don't forget that this one is the same thing as minus 4 multiplied by x raised to power minus 5. That means I can rewrite this one as what? As this. It will now become minus 4 multiplied by, from the law of indices, I can write this one as 1 all over x raised to power 5. Since it is minus 4 times this, don't forget, this one can also be 1. So we have not changed anything, okay? So numerator, that will be minus 4 times 1, minus 4, divided by 1 times x raised to power 5, x raised to power of 5. Beautiful. Am I communicating? Are we getting it? Good. Now let's go. So we have that. So Roman figure 3 now. Roman figure 3. So what do we have? So Roman figure what? 3. Let what? Let y, as usual, let y to be what? Cube root of what? X raised to power of 2. Now everybody, I need your attention here. Anytime you have something like this, the first thing you need to do is find a way to rewrite this one in terms of x raised to power n. So how do you do that? I can say, so don't just jump into the y dx. Make sure you rewrite this one, simplify this one first. Rewrite everything as power of x, that's it, so that it will now be convenient for you to perform the derivative, the differentiation. I can now say y is, that means what? I am not saying the y dx now. I want to do what? I want to simplify it first. So I'm still saying y is equal to what? How can I write this from the laws of indices? I can write this one as x raised to power what? 2 all over 3. Okay? What will now happen? Can you see this now? Now I have transformed this one into this. That means this one is now in form of x raised to power n. I have x, I have 2 over 3, I have x, I have n. That means my n here is 2 over 3. Can I say the y dx is what? Is equal to bring n up. You remember the formula. Bring it down. 2 over 3. Bring it down. That's n. Then x raised to power what? 2 all over 3 minus 1. Don't forget, okay? So I can, this is over 3 what? Minus 1. This is over 1. You can find the LCM. So now be 2 all over 3. X raised to power what? We find the LCM here. That's what? 3. 3 in 3. That's what? 1. 1 times 2. That's 2. Minus 1 in 3. 3. 3 times 1. That's 3. Okay? Are we getting it now? Beautiful. What will now be? 2 all over 3. X raised to power what? 2 minus 3. That's minus 1 all over 3. Are you with me? 2 minus 3. That's minus 1. Isn't it? Then divided by this 3. Okay? And what will that be, everybody? So it now become what? 2 all over 3 multiplied by 1 all over x raised to power 1 all over 3. Wow, that's lovely. Okay? So what will that be, everybody? So I can say this is what? 2. I can say this is 2 all over 3. Okay? Multiplied by 1 all over. Look at x raised to power 1 over 3 from law of indices. I can say this is cube root of x raised to power 1. Can you see? This 3 will come here. That's cube root. Then x raised to power what? 1. The 1 as numerator. Okay? So what will now be? 2 times 1. That is 2. That is multiply the numerator, multiply the denominator. And what? Divided by 3 cube root of x. Beautiful. Wow. Can you see that, everyone? That's lovely. So that is the first thing we are going to discuss under what? Under differentiation. Now let's go. Let's go there. Now let's now go for number 2. Number 2, okay? Number 2. So what do we want to do now? So this is number 2. Derivative of a constant term. That's number 2. Okay? What do we mean? That is, let y to be c, where c is a constant. Okay? Where c is a constant. Are you with me? Therefore, derivative of y, okay, with respect to what? Because here we don't have anything like x. Are you with me? It is just like I can say that this is just like this is just like, maybe we have x raised to power of what? X raised to power 0, which is going to be 1. Okay? Anytime we have constant like this, we just say dy, derivative of y with respect to x, because we don't have anything like x here now, isn't it? So it will be what? 0. What does that mean? That is, anytime you want to differentiate constants, derivative will be equal to 0. What do we mean? For example, so example is this. Let's say Roman figure 1. Derivative of let me say, okay, don't worry. Let's say find the derivative of, find the what? The derivative of what? Find the derivative of 100, 2. Roman figure 2, mind you. Roman figure 2, let's say minus 3 whole number 1 over 4. Roman figure 3. Okay? Let's say what? Let's say any value. Let's say 14. Okay? So, of course, solution. Since they are all constant, they don't have anything like x. So, let y, Roman figure 1, mind you. Let y to be what? 100. Therefore, dy dx is 0. Okay? Roman figure 2. Let y be what? Let y to be what? Minus 3 whole number 1 over 4. You don't need to even simplify this, just because it's a constant, it does not have anything like x. Dy dx is equal to what? Equal to 0. Okay? Roman figure 3. Let what? Let y to be, what's that? 14. Let y equal 14. Therefore, dy dx equal to 0. So, what you are saying is whatever the value you have, in as much as it's a constant and it does not have what? It does not have anything like x, then derivative will be equal to 0. Do we get that? It's as beautiful and as lovely and as cool and as interesting as that. Got it. Now let's go. So that is that by constant. Let's go, dear everybody. Now, the third one, number 3, derivative of something like this. Let's look at it too. Derivative of let's say cx raised to power n. What are we saying here? That is not ordinary x raised to power n now, but it has a particular value here, c, at the back as the coefficient of x raised to power n, and that c is not 1 now. Okay, so it can be 1, it will not be 1, mind you. So we now say, okay, let y to be cx raised to power n. Okay, and now another thing I want to show you here, everybody, is that I can say, okay, dy dx. What I'm saying is dy, you know, y is cx raised to power n. It means the derivative of y with respect to x. That means I can even rewrite it as the d with respect to a d of what? Y. Okay? And what is that y? Cx raised to power n. Can you see that? Means the derivative of cx raised to power n with respect to x, that is the meaning of dy dx. D, okay, d. Y, since y is cx raised to power n, then we have it here, cx raised to power n. Then dx. So can you see dx? That means the derivative of y with respect to x means the derivative of cx raised to power n, because y is cx raised to power n, with respect to x. What will it be? To now become multiply n power by the constant, the coefficient. See, that's n c, n times c, that's nc. Then x raised to power n minus 1. Wow, that is beautiful. Are we following? Are we getting it? So that's the formula. Now let's say example here. A beautiful, very beautiful example here is this. Example, find the derivative of, find what? The derivative, find the derivative of Roman figure 1. Okay? Let me say, okay, 3x raised to power minus 4. Okay? Let's go. Roman figure 2. Can I say 2 all over 3 x raised to power what? Minus 3. Are you getting it? All right. And what? Roman figure 3. Roman figure 3. Let's see. Roman figure 3. Okay. So what can I say there? So let me say, look at this one. Look at this one. Let me say, 4, okay, divided by, okay, cube root of x. Are you with me now? 4 divided by cube root of x. Wow, that's lovely. Okay, let's go. Solution. What? Solution. Now let's go. Roman figure 1. Let what? Let y to be 3x raised to power minus 4. Can you see, everybody? So if you compare this with this now, or let me say better still, if you compare this with this, what will you have? Y is here, y is here. Now my c now is what? 3. And I have x, I have n, so my n here is what? Minus 4. Beautiful. I can say therefore the y, the x is equal to what? B of 3x raised to power minus 4 with respect to x. Okay, that is the derivative of what? Of 3x raised to power minus 4 with respect to x. Are you with me? So what would that be? To now become, using the formula, the power n multiplied by this c, then x raised to power, you subtract 1 from n. So it will now become minus 4 times 3. Okay, minus 4 times 3. That's minus 12. Then x raised to power what? Minus 4 minus 1. That's minus 4 minus 1. That's going to be minus 12. X raised to power what? Minus 5. And of course, I can simplify this further. That's going to be minus 12 multiplied by x raised to power minus 5, isn't it? And that's minus 12 multiplied by 1 all over x raised to power what? 5. So this is like over 1, isn't it? Or your numerator, minus 12 times 1, minus 12. Denominator, 1 times x raised to power 5, x raised to power of 5. Beautiful, everyone. Can we see that? Good. So it is as lovely as that. Okay. Now, so let's go to what? That's Roman figure what? 2, isn't it? So Roman figure 2, we have done 1. So Roman figure 2. So Roman figure 2, let me demarcate this. Probably we can manage it, okay? So Roman figure 2, what do we have? Let what? Let y to be 2 over 3. 2 over 3 x raised to power minus 3, okay? Please, these are just the beginning, the basics. Definitely, I will be uploading, more videos on it so that we can get all these concepts very well, because there are so many things. Can you see? We have started with under differentiation. We have started with what? Number 1, derivative. We are still going to maybe like number 10. We have a lot of things to cover. So because we still get to chain rule, that's composite function. We get to parametric equation. We get to implicit function. You understand? That is implicit differentiation. So we still get what? The applications area. So I'll be uploading more videos on it. So make sure you kindly subscribe, share with your friends, because they will definitely find it useful. And don't forget that I also have more videos as well on Python and Java. So share, like, and subscribe to it so that once I upload more videos on it, you'll be able to enjoy it. You'll be notified and you will not miss any important concept. Because we still do what? We are still going to trigonometry go. We are still going to see how we can differentiate all the trigonometric functions like sine, cos, tan, sec, cosec. Even we can even get to hyperbolic function. So we are still coming to that one as well. So please make sure you stay tuned, okay? Now let's go, everyone. So we have y to be what? 2 over 3 x raised to power minus 3. So what do? As usual, I can say the y dx. Of course, we know that the y dx means the derivative of this guy, 2 all over 3 x raised to power minus 3. Okay? With respect to x. Okay? And what will that be? Use formula. Minus 3 times what? That's minus 3 multiplied by 2 all over 3 x raised to power what? Minus 3 minus 1. And that's going to be 3 will cancel 3. Remain minus 1 times 2. That's going to be minus 2. Okay? X raised to power minus 3 minus 1 minus 4. So now become minus 2 times x raised to power minus 4. That's minus 2 times 1 over x raised to power 4. This is over 1, right? And that's going to be minus 2 times 1 minus 2 over what? 1 times x raised to power 4. X raised to power 4. Lovely, beautiful, okay? Then finally, Roman figure 3. Then I can stop here for today. Then I will upload further video. We are not through with this. We have a lot to cover. So please stay tuned, okay? So let's what? Let y to be what? 4 divided by cube root of x. Now, please, just like the way I've told us before, don't just jump like this one now. As you are looking at it, we have to simplify and make sure we rewrite it in form of this, in form of something like this, in form of cs raised to power n. So the first thing is to simplify. We say y is what? Do you know I can write this as 4 times what? 1 all over cube root of x. Beautiful. I can write it. Very beautiful. Can you see? Because if you want to turn it back to this, 4 times 1, that's 4. Divided by 1 times cube root of x, cube root of x. So we have not changed anything. It will now become 4 times. I can write this one as what? 1 over x raised to power 1 over 3. Cube root of x. X here is what? Power 1. And I have cube root of x. Law of indices, I can write it as x raised to power what? 1. This is power. Divided by this 3 cube root. Okay? That's beautiful. I can also rewrite everything here as 4 times what? X raised to power what? Minus 1 over 3. Why? Because of this reciprocal. This 1 over. Beautiful, everyone. That's good. What will you now do? Now say, okay, can you see? We have not even found, we have not gotten to the y here, so we are still simplifying y. Okay? So therefore, y is what? 4x raised to power minus 1 over 3. Beautiful. Now we have transformed this one into the form of cx raised to power n. Now c is what? 4. N is what? Minus 1 over 3. Wow. Is that not lovely? That's cool. So what do we now do? Finally, what do we do? We now say, now I want to find the y dx. Let me write it. Y is what? 4x raised to power minus 1 over 3. I can now say, therefore, the y dx now is what? Multiply this one by 4. That's minus 1 over 3 times 4. Then what? X raised to power minus 1 over 3 minus 1. Am I communicating? Our formula, okay? So because this is n, so minus 1. This is over 1. I can write it as that, isn't it? And that's going to be minus 1 times 4, everybody, minus 4 over 3. Okay? X raised to power what? What's the LCM? 3, okay? 3 in 3, that's what? 1. 1 times minus 1, minus 1. Minus 1 in 3. 3. 3 times 1, that's 3. Okay? What will that be? That's going to be minus 4 all over 3. X raised to power what? Minus 1 minus 3. Minus 4 divided by 3. Wow, that's lovely, everybody. Is that not beautiful? Yeah, of course it is. So let's go. We now have what? Minus 4 all over 3 multiplied by x raised to power minus 4 over 3. I can write it as minus 4 over 3 multiplied by 1 over x raised to power 4 all over 3. You know, reciprocal. So the minus will go, okay? So now become minus 4 times that. That's, or before then, I can write it as minus 4 over 3 multiplied by 1 over what? Cube root, that is 3 at the denominator will come here, cube root of x raised to power of 4. Lovely. Now, numerator, minus 4 times 1, that is what? Minus 4. Now multiply the denominator, so 3 times 3, that's 3 multiplied by cube root of x raised to power of 4. Wow. Welcome back, everybody. This is beautiful, this is cool, this is interesting and lovely, okay? Now, finally, you remember that I always give you gifts, right? So that is that about that. So finally, the gift I have for you today is this. The gift for today, I always give you beautiful gifts after all the classes. So the beautiful gift I have for you today, exercise, okay? Exercise. Find the what? The derivative of Roman figure 1. Okay? Let me say 3 all over 5, then x raised to power what? X raised to power 2 over 3. Okay? Then Roman figure 2. So 5 all over 2, or better still, let me say 5x squared, okay, divided by 2 root x cube. Are you with me now? So differentiate these two. Differentiate them. These are the beautiful gifts I have for you today. So kindly subscribe, don't forget. Share also with your friends, your loved ones, so that they will find it useful, okay? So see you later. Thank you. So I will upload more on this. So we continue from where we stopped, okay? Bye. Take care. Make sure you do it, okay?